Find the least common denominator, which is, can anyone give us the least common denominator here? So the limit operator does not go away. T plus 1. Awesome. There are two factors. One is t, the other one is t plus 1. Both factors have to be in the least common denominator. So then, adjustment for the top of the first one. Adjustment for the top of the second one. Exactly, or 1. Perfect. So can you please tell me what to do next? Very good. These two go away. Do not drop the limit operator. Exactly. T divided by t is 1. T divided by t is 1. So I finally get to limit as t approaches 0 from 1 over t plus 1. This is a ratio. It's fully simplified. If 0 is in the domain, I'm done. There is nothing else required. If 0 is not in the domain, then I have to be careful. Is 0 in the domain of this function? So what is the answer? Before we look at an example of absolute value, so I do have here something like this that I would like to show you. Maybe I will assign this and just show you another problem that I can ask you to pick from the book for this. But before we do that, I would like to show you number 11. It's a very important theorem. It's called the Squeeze Theorem. The Squeeze Theorem. Okay, let me explain what happens here, and then we'll look at an example. Okay, let's suppose I have a function. This is a function. Let's say something like this. And let's say I have another function. Let's say something like this. And near a particular point, let's say near 1, I can show you that there is a function that is squeezed between these two. I don't know what happens at 0. I don't know what happens at 5. I don't care. But around 1, near 1, this function and this function squeeze a third function in between. So now if I show that, I'm asking you this. If the limit from either side of this function approaching 1 from either side is 5, and the limit of this function as x approaches 1 from either side is 5, what will be the limit of the squeezed function when x approaches 1 from either side? That's the squeeze theorem. So here is again the picture that I showed. So this is function f, this is function g, and this is function h. And let's say that limit of f of x as x approaches a from either side is, let's say, L, and limit of g of x as x approaches a from either side is L. And I showed that h of x is squeezed between g of x and f of x, specifically near a. What do we mean by near? In an open interval. Open interval. So this is the first hypothesis. This is the second hypothesis. From 1 and 2, I conclude that the limit of h of x as x approaches a from either side must be. Okay, now you can say, before we look at examples, you can say, really, why would I ever need to do this? Here's when. When I have no idea how to determine this limit. I have no clue what to do. Then I'll say, oh, maybe I can show that this function is squeezed between these two functions. This one is very easy to find the limit from. This one is very easy to find the limit from. And they are both the same. Then I don't have to do anything with h. My hands are tight on h. Too difficult. I don't know what to do with it. But I show that that h of x is squeezed between two functions near a, not here or here. No, I don't care for that. I hear right here, around a, near a. It's squeezed. And then I'll conclude. If these two are the same and they exist and they are the same, then this will be. Here's an example. Okay, on page 107, I like to look at that 36 or 39, doesn't matter. So let's say limit as x approaches 0 from x to the fourth, cosine 2 over x, and this is problem 39 on 107. We're basically asked to prove that this limit is blah blah blah, but I just don't want to look at what they said the limit equals to. We'll come up with our limit, and then we'll look and see if they came up with the same thing. So every time I'm asked to find the limit, what is the first step? Okay. But I don't have an answer. Here's why. You're right. This is what I have to do, but I have no answer here. So this is 0, and this is cosine over undefined. Cosine of undefined. What is cosine of undefined? And you cannot say it undefined. I don't know what it is. Even if you say undefined, 0 times undefined doesn't necessarily equal 0. So I don't know how to handle this. Okay, so now I'm going to decompose it in two pieces. First of all, I'm going to say, forget about x to the fourth. Let's think about cosine of 2 over x. What do we know about this function? How high can cosine be? Very good. How low can cosine be? Perfect. So this is what I know so far from our past experience, that cosine cannot be more than 1 and cosine cannot be less than -1. Awesome. So I created this piece. I have this piece. It's right here. It's bounded below by -1, above by 1. What do you think I am going to do to all these three sides to get my h of x? This is what I want. I want my h of x. What should I do to all three sides to get my h of x in the middle? Nope. What is h of x? X to the fourth times cosine. Multiply to the fourth, but I have to be careful. I will multiply all three sides by x to the fourth, only if x to the fourth is a positive number and x to the fourth is not 0. Otherwise I can't, because the symbols will switch. But is x to the fourth always positive?
Yes.
Of course, x to the fourth is always positive. Is x not equal 0? Yes. How do I know? Because x approaching 0 specifically says x does not equal 0. So I can multiply. So then I have negative x to the fourth, x to the fourth, cosine 2 over x less than or equal to x to the fourth. So this is my h of x. Can anyone tell us what is this? And can anyone tell us what is that? This is my h of x. This one is, and this one is? Good. So f is at the top, g is at the bottom. The other way around, sorry. I said it, but I wrote it incorrectly. It doesn't matter. The notation is not important. I can change here f and g. It doesn't matter. So it's between two functions. That's good enough. Good. So the first hypothesis of the squeeze theorem is proved, right? It's complied with. We showed that our function that we know nothing about is definitely squeezed between two other functions. One function is at the bottom, negative x to the fourth, and the other function is at the top, which is x to the fourth. Now I have to show the second step. What is the second step? That the limit of negative x to the fourth as x approaches 0 from either side, and limit of x to the fourth as x approaches 0 from either side, in other words, f and g, they both exist, and they are the same. I'm determining the limit of a polynomial. How do I determine the limit of a polynomial? Good, so what do I get? What do I get? So now from 1 and 2, comma, by the squeezing theorem, or squeeze theorem, I conclude that the limit as x approaches 0 from x to the fourth cosine 2 over x must be, that's it. But you understand, two conditions have to be fulfilled. I have to find those functions, and I have to determine and show that the limit of those two functions exists and they are the same. If this is 5 and this is 3, the squeeze theorem does not apply. So I show that h of x, without even determining this limit, I show that this function is squeezed between these two. That's the first step. Then I determine the limit of this and the limit of this. I show that they exist and they are both the same. And now I can conclude immediately that the limit is 0.
Oh, because you put 0 in. Okay.
Because these are polynomials. So you can say, fine, this is wonderful. But when do you use this? Here's when I use it. Okay. So the problem we picked was this, but this is when I use it. When I don't even have the function. So I'm not even giving you the function, I'm asking you to find the limit as x approaches 1. And you can say, give me a function. I don't need to. Because if the squeeze theorem is applicable, all I have to tell you is that this function is squeezed between these two on a certain open interval. And then I'm asking you to find the limit of g of x. And I don't even give you the function. So it's a very useful theorem. So let's do one of those problems. So let's say 37 on the same page. We are told that 4x minus 9 is less than or equal to f of x, which is less than or equal to x squared minus 4x plus 7. For everything greater than or equal to 0, we're asked to find the limit of f of x as x approaches 4 from either side. Oh, yes, I'm sorry. Oh, I'm sorry. I guess I forgot to zoom out. So 4x minus 9 less than or equal to f of x, which is less than or equal to x squared minus 4x plus 7. Okay, so is the first hypothesis of squeeze theorem fulfilled? Yes. It's already given to us. So the limit, so this function is clearly squeezed between these two. So this is the bottom one, and this is the top one. The name is not important. Good. So this is the first condition. Now the second condition, so this is number 1. What do I have to show? I have to show that the limit as x approaches 4 from 4x minus 9, as well as the limit as x approaches from 4 from, very good. They both exist, but not only do they exist, these are polynomials, obviously they exist, the limit exists, but also that they must be the same. Only then I can conclude the limit of this, which I don't even have. I don't even know the function. So the first one is 16 minus 9 is 7. The second one is 16 minus 16, which is 0, plus 7. So now I will say from 1 and 2, what do I conclude? By the squeezing theorem. I have to mention that. What do I conclude?
The limit of x
Of f of x.
as it approaches 4.
So I would like you to work on this one. Do you need to? Exactly. So it's the x to the 4th cosine 2 over x. That's the limit. Okay, I still have like 9 minutes, so I would like to finish this section with absolute value expressions.
Can you show, you put that up just 1 second?
Does it make sense?
Yeah, so basically,
Yes, go ahead.
yeah, it makes sense.
It does?
All equals 7, yeah.
Because if I show that the function is squeezed,
See 7 on both sides.
if the limit here is 7 and the limit here is 7, even if I don't have the function, the limit of the squeezed function must be 7. Okay, so I would like you to choose now an absolute value limit, and then we can say that this is done. So I would like you to choose anything from here because I picked this absolute value functions. So here, this is very clear, right? You're going to factor. And you're going to eliminate, in this case, which factor, hopefully? X minus 2. This one we're going to address right now. The same thing here. You're going to try to clean it up and then see what happens. Here, you will have to find the domain as we did last time, right? And then find the limit. Here, we already did this problem, very similar today. This is a piece of cake because you can apply the limit law, which is very simple. As x approaches 2, this limit exists. As x approaches 2, this limit exists. You apply the limit law and you're done. And this one, I don't want you to do this one without me. So hold on, hold off to that. So not 12. I want to do a problem first with you. Okay. So please choose from 40. Which one?
43.
Okay, 43 it is. Yes, 43 on 107. So we have limit as x approaches 1/2 from the left from 2x minus 1 over 2x to the 3rd minus x squared. It is easier than you thought, yes. I completely agree. Okay, in a limit like this, first of all, I will have to take the function aside and simplify it as much as possible. So don't look at anything else.
Without x squared.
Say it again.
Without x squared.
Yes, yes. Okay. So we have a 2x minus 1 divided by, this is our function, f of x, the absolute value of 2x cubed minus x squared in absolute value. This is the function. First, I will have to start with a piece that is the absolute value. So the absolute value of 2x cubed minus x squared. Yes, I will factor out x squared as a very good starting point. And then I have 2 minus x. Agreed?
No.
2x minus 1. Thank you. I'm so happy you disagreed. Thank you. You should never agree with that. Good. Now, there is a property of the absolute value that allows us to change the absolute value of a product into the product of the absolute values. And this is what I'm going to do next. So this is the absolute value of x squared, 2x minus 1. And does the absolute value make any difference on x squared? No. So all I need is to do this. Perfect. So now, there are two possibilities. For x squared times the absolute value of 2x minus 1, there are two possibilities. I know I have 5 minutes. I'll hopefully I can finish in 5. So what are the two options? One option is x squared multiplied by 2x minus 1 if 2, not x, but if 2x minus 1 is greater than or equal to 0. And the other option is negative x squared times 2x minus 1 if 2x minus 1 is less than 0. Do you remember this? Should I state the formal definition of the absolute value on the side note here? So here it is. The absolute value of, let me write any expression in absolute value is the expression if the expression is greater than or equal to 0, or negative the expression if the expression is less than 0. And that's what I did. So it's the expression if the expression is positive or 0, and it's negative the expression if the expression is less than 0. I only mimicked this. And now I have to continue and write x squared 2x minus 1, and I have to solve this. So x greater than or equal to 1/2, or negative x squared 2x minus 1 for x less than 1/2. After all this work, I'm finally ready to go back to the function. So then the function, which remember is 2x minus 1 over the absolute value of 2x cubed minus x squared, has two options. What are the options? When the denominator is replaced by this, what do I get? 2x minus 1 goes away with 2x minus 1, and I get 1 over x squared. I can no longer include the equal symbol because now this is in the denominator. So for x greater than 1/2. What is the other option? When the denominator is this, I still simplify 2x minus 1, but what is left? Negative 1 over x squared for x less than 1/2. And now I can answer the question. What was the question? Limit of the function as x approaches 1/2 from the left. Which branch will I use for 1/2 from the left? Yes, and that's why we did all those absolute value expressions. Yes, Paul? Yes. So when this is this, which is this, I will simplify the 2x minus 1 with 2x minus 1 from the top, and I only have an x squared left in the denominator.
Oh, right. Substitution. Okay.
Right. And then the other option is this. 2x minus 1 goes away, and now I have negative 1 over x squared. So finally, limit of the function as x approaches 1/2 from the left. Which branch do I use? That's why we did this in pre-calc. Limit as x approaches 1/2 from the left. Which of the two branches will I use? Top or bottom? Bottom. Negative 1 over x squared. What do I get? 1/2 is in the domain. All I have to do is plug it in. So 1/2 squared is 1 over 4, and I have to flip it. So this is 1/4, and I have to flip it because I divide. Negative 4. Negative 4.